Welcome everyone to the 24 Hours of Pass Summit Preview 2018. We're excited you could join us today for Lyndsey Padget session, Git, Concepts and Strategies. The 24 Hours of Pass consists of 24 consecutive live webinars delivered by expert speakers from the Pass community. These sessions will be recorded and posted online after the event. If you have registered previously, you will receive an email letting you know when the recordings are available. My name is Brian Kelly and I'll be your moderator today. Before I hand over the reins to Lyndsey, I do have a few introductory slides for Pass. If you require technical assistance, please type your question into the question pane located on the right side of your screen, and someone will assist you. This question pane is also where you can ask questions throughout the presentation. Lyndsey will be taking questions at various points and will not wait till the end. So as soon as you have an idea or a question that you want to ask, go ahead and type it in and we will get to it at that portion. You are able to zoom in on the presentation content by using the zoom button that is located on the top of the presentation window. Please also note that there will be a short evaluation at the end of your session. Your feedback is always important to Pass. We use it for basically ensuring that we're on target. This will arrive as a pop-up after the webinar ends in your web browser. And just a moment to thank our presenting sponsor, Quest. The staging of 24 Hours of Pass would not be possible without their generous support, and they are the reason that this event is available free of charge. If you would like to learn more about Quest and sign up for information on how they can help you, please visit the sponsors page on the 24 Hours of Pass website. Pass is a global not-for-profit association where data professionals connect, share, and learn. Pass is totally free. It gives you access to hundreds of hours of free online content, live virtual and in-person events. There's also local groups that you can join, hopefully in your area. And there is also the opportunity to attend the annual conference, the Pass Summit. Pass is a great way to connect with like-minded professionals, to increase your technical expertise, and to grow your career. So it's my pleasure to present for this past session Lyndsey Padget. Lyndsey is the founder of Long Play Software based in Kansas City, USA. She is a full stack developer with over 14 years of software and web development experience at both mega corporations and startups. Lyndsey enjoys sharing in-depth knowledge on topics such as mean stack development, microservices and REST, Git and release management, test-driven development, Agile and Kanban, healthy teams and individuals, public speaking, and more. Lyndsey is involved in local organizations that encourage women, young and old, to explore careers in math and science. She also believes that the difference between a decent software engineer and a great one often has very little to do with code.
All right. If you guys are ready for me, I'll take over. Can you hear me okay?
We can.
Okay, great. Okay, thanks Brian for the intro. Today I'm going to be talking about Git, source control management that is near and dear to my heart. Just for those of you who are new to it, understand that the learning curve is quite steep, and I never thought I would be in a situation to be teaching others about Git, because the first time I used it I thought, oh, this is not for me. I had come from systems such as Team Foundation server, version, things like that. So without further ado, I want to get into how I'm going to kind of break this down. I'm going to give you a quick overview of Git and how it might best be used in your specific situation, ergonomics, if you will, to make it easier for you. Then we're going to talk about some Git basics. If you have already been using Git, I will warn you that some of these may not be new concepts to you, but I encourage you to hang in there because we're going to get into some advanced topics pretty quickly. So we're going to talk about branching for a little while, and then how branching and tagging get into release management. Then we're going to talk about how the different systems interact with each other. That's the now it gets fun section, as it relates to Git being a distributed system. Staging, because that's always a little bit strange. You're doing that on your local system, but just kind of getting that flow down. Advanced concepts can be really handy when you get yourself into what I call a Git pickle, and you're trying to get yourself out of one. And then finally, the miscellaneous but oh so useful. These are things that I use every day, but didn't really belong in any of the other categories. So let's get started. Normally I kind of gauge where everyone is as far as Git skills. And since I'm not in front of you today, you'll have to kind of gauge for yourself what your Git skill level is. But I do want to stress the importance of using Git on the command line. If you use a tool such as source tree or Git Kraken, things like that, more power to you. But I truly believe that the true understanding of Git is found on the command line. It makes it so that you really understand what it is that you're typing and what it is that you're doing. And Git also gives you a lot of feedback in the terminal to tell you what you should do next, right? If you're doing this or that command and you maybe do it wrong, it's going to give you the man pages so that you can see what you might be missing. So that's a learning opportunity right there. I mainly use a Linux system, so I use Oh My Z Shell. I have switched over to Mac recently. Oh My Z Shell still works fine for me, but if you're on a Windows environment, you'll probably want to check out something like Git Bash or Padget. Padget is the one that somebody had me recently. As a Windows developer, I feel like I just can't live without it. So those are two kinds of terminals that I would recommend checking out, because once you beef up your terminal and make it really, really ergonomic and Git friendly, then you won't feel like you're just poking around in the dark. You'll have a lot of visual cues and help right there available. Not to mention it feels good when you're working in it day in and day out. On that note, since I do stress learning Git on the command line and using it on the command line, it may be necessary for you to brush up skills, as in Unix bash type commands. So again, if you're on a Windows, this might vary slightly. You might use Cygwin or some of these other kinds of things, but this code series, it's not a code, it's a learning series. Learn Code the Hard Way has several different resources available, and the Unix link that I've put here is particularly handy. I think it's a downloadable PDF for a small fee. And then if you are looking for a purely free resource, this book is actually a free download, and you can get it in different formats, different mediums on the Git SEM website. You can also buy a copy if you want it in paper edition, but the download is free and it's pretty massive. I think of it like a reference guide. And then before I proceed further, I just want to clarify, because this is really more of a pet peeve than anything else. Git is a source control management system. It doesn't really have a brand to it. GitHub, which is obviously very popular and recently acquired by Microsoft, is the leader in this space, but you've also got Bitbucket, which is by Atlassian. So Bitbucket Server is what would be comparable to like a professional version of GitHub. You've also got GitLabs. And then I put the picture of the chimp there because you can actually create your own Git server anywhere you'd like on that old PC sitting under your desk, if that's what you'd like to do. And especially in situations where you need on-premises Git hosting, that's definitely within your capabilities. And then as that relates to overall source control management, Git is this umbrella where all of these different providers fall under it, but then you've got other types of source control, like I mentioned before, things that I had used in the past, such as Team Foundation Server, Mercurial, that's always a tongue twister, and Subversion, maybe even CVS or SourceSafe. Those would all fall under that category. Okay, so let's get into the basics. you've got NinjaCat here. NinjaCat just has a file, a folder on his computer. When you type git init, that is actually going to initialize a Git repository in that folder. And it does so by creating a hidden .git folder. And that's where all of the goodies for the inner workings of Git reside. I will not go into the inner workings of Git because I'm trying to keep this very pragmatic, useful day-to-day information. You can absolutely get into that folder if you're trying to recover something, but you should proceed with the utmost caution. And by the way, the commands, most of the time, the commands that I list in the corner, they'll either be in the lower left corner or maybe the upper right corner. Those are things that the commands that you would actually type into the command line. So for example, if I'm NinjaCat and I'm in this empty folder and I type git init on the command line, that's what will happen. It will initialize a Git repository. Git clone is the process of taking a repository that is somewhere in the cloud. And just for brand neutrality's sake, I have, NinjaCat here, which is obviously from the GitHub Octodex, but I've used a Bitbucket URL. It actually doesn't matter. It doesn't matter what cloud provider you're pulling it from. The point is that you're trying to get a repository from the cloud down to your local device, and that would be the git clone command followed by a URL, like so. Forking is different in the sense that it is still a copy, but both copies are in the cloud. So when AdventureCat comes along and wants to copy NinjaCat's code and host it under her AdventureCat account, she would use the git fork command. Now, you may not be familiar with using git fork on the command line because that's normally something you do in the cloud, right? If you're using GitHub, for example, there's a nice button right there that says, fork, and it will automatically copy it to your account if you're logged in. Remotes are the connection between repositories. So in all of these cases so far, we've had these dashed lines. Each dashed line is a kind of remote. And you can think about remotes as though they're the remote between your hand and the TV, right? That's what a remote control does. So that's kind of how I remember it. By default, the common naming convention for the first clone that you pull down, the name of that remote is called origin. That can actually be named anything. You can rename it later if you'd like, but origin is just the default name that you get. So, and normally people only have one remote, but we'll talk about many. So in this particular case, AdventureCat may decide that she wants to also have a connection between her local repository and NinjaCat's repository up in the cloud. That would be considered upstream, again by common naming convention. So she can add a remote, which is just a connection there, and call it whatever she likes. But because this is the original repository where the code came from, upstream is a common way to name that remote. Now, in reality, AdventureCat may not know NinjaCat. And in that case, you can create an upstream remote, but you can't actually push your code to it. You can't get code from your local machine up to NinjaCat's repository. And that's why I've grayed it out there, because it's really only a pull scenario. You can pull, but you can't push. So this is more typical of a real life scenario where AdventureCat will change some code in the local repository. She'll push it up to her account in the cloud, her repository in the cloud, and then she'll create a pull request, which indicates a desire to merge that code into the original upstream repository. Are there any questions so far?
Not so far.
Okay, great. Just enough time to get a swig of coffee. All right, let's proceed in talking about branches. Again, if you've been using Git for a little while, bear with me because you may know some of these things already, but essentially you've got an empty repository when you begin. The interesting thing is, because you haven't committed any code yet, there isn't a branch yet. There's no need to have a branch. There isn't any code. So the moment that you create your first commit is when the master branch now exists. Again, there are these common naming conventions in Git, and master happens to be the common naming convention of the first branch that is created. But you can actually rename this branch to be whatever you like, if you want. I wouldn't necessarily recommend that since that's what people are used to, but if you have a really good reason for doing so, by all means. So each of these dots represents a collection of changes, meaning that if I have 5 files in this repository, each of these dots represents 1 to 5 files that have been changed or added or something like that. When I say git checkout -b feature 123 on the command line, it is going to create a new pointer. These are called refs, and specifically this is called a head ref because this is sort of the end of the tree. It's a leaf in the tree if you think about this being kind of upside down. So now I have a new branch, but the interesting thing is that the pointer, the head pointer, just points to the same commit. Each of these 3 dots is a commit, and because nothing has really changed, it points to the same place. If I then change some code and say git commit that code, it will diverge from the master branch. Merging is the process of taking a series of commits in a particular branch. Again, this branch is called feature 123, and merging that code back into wherever you want it to go, or wherever it came from, which is in this case master for the sake of simplicity. Note that when feature 123 gets merged back in to master, if you could see my cursor here, this commit right here is called a merge commit. And that is essentially the union of all of this code on top of whatever existed here. Occasionally, you may run into conflicts. Now, a lot of people don't realize this, but the Git platforms have been trying to get smarter and smarter and smarter about how to merge code automatically, whether it's PHP or Java or C# or SQL, whatever it is, that it's going to try to merge it for you, but sometimes it just can't because it's not sure, and it really needs a human to intervene and say, I don't know which of these sets of code is right, and maybe it's actually a combination of both, because if, say, for example, 2 people have changed the same line in this commit and also in this commit, that's likely going to result in a conflict that needs to be resolved. And by merging, you actually resolve the conflict here, and it doesn't, so this is a bit of a misnomer, but it doesn't actually create the merge commit until you have resolved the conflicts. Any questions at that point?
We do actually have a couple coming in. The first one is the question on the previous slide: is feature 123 a separate file or a set of files?
Neither, actually. So if you're familiar with TFS, each branch, and I'm going to use that term loosely because that's not really what they call it, is a set of files. And so that question may have stemmed from thinking about it in that way, but think instead of branches as an alternate universe. So when you check out feature 123 as the branch, it's a different universe that these files are now in. So it's the same files, but they have different sets of changes applied to them. Hopefully that makes sense.
One comment that was made is that they think that the pull is a a bit confusing as far as naming because they think Git rather than merge. Maybe you could speak to that.
I think that the clarification between pulling and pushing and merging will hopefully be evident by the end. But just as a quick rehash, pulling is the process of getting your local device to be aware of what code has changed in the cloud, and then also take that code and assimilate it into your local code. So we'll talk about pulling in more detail later. But what was the other part? Pull and cloning?
They said they were getting a little bit confused because when they hear the word pull or think of the word pull, they think Git rather than merge.
Okay. I have a slide later that will make this all apparent, I promise. I understand the confusion though, and a lot of it with Git is just retraining your brain to associate words with new meanings because you may have associated those words with something else, especially if you've used other source control systems. It's not unlike learning a new language in code where const meant one thing in this language, but const means something else in another language. So kind of keep that in mind. Was that it, Brian, or were there any others?
One last question, and it's this: is there a good way to handle binary data files and code sets like with Power BI?
Okay, so by binary code, I'm assuming like large images, videos, things of that nature. I'm going to assume that maybe that's what we're talking about. I actually keep those things, so especially videos, I keep those in like a CDN type provider. Amazon S3 is what I used for my last Git repository where I had a lot of videos. Images really aren't too bad, but it depends on the number of them, obviously. And it is worth mentioning that once you commit those to Git, they're always there. Even if you delete the images, they're still there in the history. And so you really want to be careful. The person who asked this question is correct in thinking that you need to think twice before introducing large binary files into the Git umbrella, so to speak. And so, yeah, oftentimes the most appropriate place for that is some sort of other cloud provider, but not if you have to version them, right? So it just depends.
Okay, I think we're good.
Okay. All right, so let's talk about release management. You can actually create human readable labels on commits. Each of these commits, each of any commit in a Git repository has a SHA hash associated with it. That is just the binary way or hex way, I guess technically, to identify that commit. But it's not very user friendly. It's not very human friendly. So especially when it relates to releasing, you have the ability to tag a particular commit. And what I recommend to folks is to try to create a tag that would indicate a release candidate. Take that all the way through your pipeline, whether it's dev, test, staging, and then on into the live environment. Whenever you're thoroughly convinced, or whenever your QA department is satisfied with the validity of that release, then you can actually apply another label. So here I've shown that 1.0 is also known as Pegasus, right? So you can have a 2.0 release candidate tag, but then also call it 2.0 because it was a release candidate and everything passed QA and now it's good. So that's something to consider, is how tags can work into your workflow as far as your release workflow. You can also get back to these tags at any point. So just like any commit, you can get back to it if you need to fix something and make a hot fix. The other thing I'll mention about tags is that there are heavyweight tags and lightweight tags, and I'm not going to dive into the differences between them here, but you may, before starting to use tags for your organization, you may just want to read the documentation between those two to decide which is correct for you. Like I mentioned, a hotfix is, again, this is just sort of by common naming convention, but a hotfix is typically a branch that immediately comes off of the master branch, if that's the code line that customers or clients are going to get. You call it hotfix 237 or what have you, and then you make this quick change and you merge it right back into master. It's really just like any other branch. Yes, you could make changes on the master branch directly, but I don't recommend that because I like to set up branch protections. So I actually just wrote an article about some of the ways that you can protect your code using teams and organizations in GitHub specifically. You can feel free to check that out if it's relevant to you, but the point I really want to get across is that the master branch is gold, and you don't want people, especially anyone on the team, just pushing to it willy-nilly. So even though it might seem silly, if you have a hotfix, making a quick branch and then merging it back in is actually the safest way to proceed. Now, for all other kinds of development, you know, hotfixes should hopefully be the exception and not the rule. A lot of people use Git flow, and then I think it has some kind of variant little cousin called hub flow. These are just ways of using Git. They're really nothing more than a set of standard processes for people to follow so that people don't get confused. So I'll show that here. I've got the master branch, of course, and again, master is supposed to represent what your customers have, or what your clients already have, the released version of your code, where develop represents the version of code that they will get soon or next. So in this particular case, develop might indicate the work that is going to be 2.0. And of course, the develop branch was made right after the 1.0 tag was applied. You don't have to do any of that in a certain order with Git, but these are the tools you have in your toolbox, right? And that would certainly be a very reasonable way to proceed on something that would have this kind of release cadence. So develop indicates what might be 2.0, or maybe we'll keep working on develop and then decide what to call it, right? And then off of develop, you would have a feature branch like feature 123, which I showed earlier. Develop is supposed to represent, you know, the version of code the customer will get in the next month or the next 3 months. And then feature 123 might be the feature you're working on this particular week to add a button and make it shoot fireworks out of it. You know, the old school JavaScript marquee stuff. So whatever your feature happens to be, that's kind of how that would look. Squashing is the process of taking many commits. I'll go back and show you. In this case, I had 2 on feature 123 branch. And squashing is the process of taking those 2 or those in commits, however many you'd like, and bundling them all into one. And there are various reasons for doing this. One of the reasons, and I'm half joking with this commit message here that says, I'm so smart, I did this in one commit. The reality is that you will run into situations where you have to push something live or, you know, to a test site to actually reproduce some problem. And so then your Git commit logs get cluttered up with commit messages like, okay, try this. How about add a space here? How about this? Does this work? And before you know it, you have 10 or 15 different commits that are just poking at the code and not really fixing anything. And when you're done with something like that, I would recommend squashing. Now, squashing, when pushed up to the repository in the cloud, is going to rewrite history. That term rewrite history is something you may have heard of and been urged away from. But in my experience, rewriting history is not that big of a deal if you are on your own branch, right? If I'm the only one working on feature 123 branch and all of these commits are mine, then I can usually do whatever I want on this branch and no one has too much to complain about. What they really want is to see that code merged into develop or master, and that's where you would have a pull request. So that's where people start to care. But you can talk about it with your team or decide for yourself what you feel comfortable with. SimFlow is a bit of a shameless plug for an article that I wrote that simply challenges the common naming conventions I've talked about here. So in my particular case, I needed to version a REST API. And Git flow is great, but it does have the built-in assumption that the master branch is what people currently have, and the develop branch is what they're going to get. And that way you can really only have two things in development at once, or that's what you're supposed to do. In my team's case at the time, I had a need to maintain many versions of a REST API at one time. Now, trust me, that's not ideal, but it does happen. And because of that, we started to rethink the way that Git flow works and where it wasn't necessarily fitting our situation. So I proposed this concept called SimFlow. There's a document actually published out on GitHub that you can go read. But all it does is challenges the naming convention so that master becomes V1, develop essentially becomes V2, and then V3 becomes the next version, the develop on the develop, if that makes sense, because you're going to have to maintain many of these at once. If you have a feature like feature 1, 2, 3, you can merge that into the V2 branch, but then you can also carry it over to the V3 branch if that's what makes sense. We'll talk about how to carry commits over here in a moment. So any questions on that so far?
We do actually have several. I'll put two of them together because they make sense. The first one is does Git set the major minor, subminor release numbering system, or is that controlled by the user? And kind of along with that, in the slide where you had hotfix 237 between version 1 and version 1.1, does creating hotfix 237 then create version 1.1 automatically?
The answer is no. Really to both questions, because the naming convention that you use for tags is totally up to you. Now, you can get a little bit smart with your tooling. If you think about it, Git is giving you the full range of capability. So if you want to have alphanumeric characters in your tag names, that's fine. But if you don't want to allow that, then you may want to set up a process. So for example, I've done this in Jenkins, and choose your continuous integration tool that is your favorite. But in Jenkins, I know that I've set something up where the QA person can actually tag a release because they're the one who's testing it, right? And I've made it so that they can only adhere to a certain regex. So it has to be v1.1.2 or v3.4.5, right? And tags are easy. You can remove and add tags at will. So if you make a tag and it's not named correctly, you can always go back and either remove it or make a new tag and just have two. That's totally fine. But it is it has the utmost flexibility and it doesn't enforce its own. But I think that there are tools out there that can help you do that.
Okay. And another question, is the Git local the same base SCM as found at GitHub? I think this goes back to the previous section.
Okay, Git local as in the local repository, I assume. So yeah, each Git repository is a completely independent copy. And you can almost think of it like a history of changes, a database that is filled with, I'm using the term database loosely, but it's a database filled with the delta changes between files in the repository. So the local repository that you have on your system really isn't fundamentally different than the repository found on the GitHub website. If you had some sort of godlike powers and you were able to SSH into the GitHub or Bitbucket server machines directly, you would see that it's just a Git repository like anything else. And since we were just talking about continuous integration, you may notice if you start to get into, Jenkins, Travis, TeamCity, and the way that it builds code, oftentimes it will check out the Git repository. It will clone the Git repository, I should say, from scratch on a brand new sort of fresh working directory. And the Git repository that you have there really isn't any different from the one on your local machine either. It's just a copy.
Okay, and a follow-on question to the one that was asked earlier, can Git create a hotfix that will create version 1.1 from version 1.0?
Not that I've seen. I think I'm trying to think if there are any tools that would do that for you. Because I use Git primarily on the command line, it is possible that the UI tools like Source Tree or even what's built into Visual Studio Code, Git Kraken, maybe things like that exist in those tools. I personally don't like the tool to do that for me. I wouldn't want it to do that for me. It seems a bit cumbersome, but once you get comfortable on the command line, and this sounds a little silly, but when you're typing it out, first of all, it doesn't take that long. And second of all, it gives your brain a split second to say, wait, what am I doing? Am I doing the right thing? Am I branching from the right place? Am I merging into the right place? Because once you get comfortable with Git on the command line, the overhead to create a quick hotfix is very, very minimal. And I would argue that if there is any small overhead of doing it just by typing it out, it's a safe, good overhead because it gives you a moment to think about what you're doing.
All right, I think that's all for right now.
Okay, just my opinion on some of those things, but I'm trying to demystify Git here, and I think that doing it on the command line is a great way to do that. So, okay, so now it gets fun, and we're going to circle back to pushing and pulling, which was a question that was asked earlier. Real life starts to look like this, and this is a very simple version. So you've got, NinjaCat, and maybe NinjaCat is the one that created the repository, and he's over there working on a hotfix. And off of the master branch, you've got develop, so they're using Git flow in this case. SpideyCat is working on feature 875, and MegaCat's working on feature 123, and Stormtrooper Cat really needs the code that MegaCat is working on. And I really want to talk about this here because you can absolutely 1000% branch off of branches. That is one of the many things that makes Git very powerful. And I like to bring that up whenever anyone on my team might say, well, I can't work on that because I'm blocked by blank. I would say, well, that is a great opportunity for the two of you to work together. And then they would say, well, I don't want to work on the same branch. We're developers. We like to keep everything in our own yard, so to speak. And it's like, that's totally fine. What you would do is you would branch off of MegaCat's feature 123 because maybe MegaCat is working on a button, and that button is going to emit some sort of event. And Stormtrooper Cat has to do something when that event is fired, right? That's a pretty simple example, but it's a great way to get people to collaborate and say, you know what? If you could just make the event emitter first, so that Stormtrooper Cat can branch, and then if if MegaCat comes back on feature 123 and says, you know what? I actually want to change the way this event emitter works because this branch is a descendant of feature 123. Stormtrooper Cat can then have the choice to update and get the latest developments, the latest commits on feature 123. So hopefully this diagram illustrates how teams can really work together, and Git really eliminates friction and the hurry up and wait that often happens with development teams because Git gives you the power and the flexibility to keep on moving, and then when things are ready, you can catch up later. The big picture would then look like this. AdventureCat has pulled this repository down to her local device, and she would really like to collaborate with this team. You know, there's a team of at least 4 people up there in the cloud doing things. And of course, they didn't do it in the cloud. They did it on their local machines and pushed it up to that, that original bitbucket.org/NinjaCat repository. But AdventureCat has this local repository, and that local repository actually doesn't know anything about that development that has happened up in the cloud. The process of making her local repository be aware of those changes is a fetch. Git fetch will make everything that has happened in this repository or this repository, whichever you specify, and take all of that history and just download it to this local repository. Now, we've talked about Git being a distributed system, and what that means is that AdventureCat or whoever is using this, this whole system and interacting with this repository can work offline. So AdventureCat can work if she is on an airplane or in a car, you know, someplace without Wi-Fi, continue making commits to the local repository and push them up whenever the time is right. And it goes both ways, because fetching is the process of syncing the two up as far as histories go. Things have been happening up here in the cloud. Maybe she's been on vacation for 5 days. When she comes back, doing a fetch is going to be recommended because, you know, the code in this local repository is not fresh anymore. Merging, on the other hand, as it relates to syncing up repositories, is the process of moving the head. And remember that head is just a pointer to a particular commit. By convention, it's the last commit in the tree. So previously, AdventureCat knew that this was a commit. That was as much information that the repository had. But after a fetch, then you could do a merge on master, and the pointer moves, because this is actually where the rest of the team is. So fetching and merging are really 2 separate things. However, note that pull is a fetch and a merge simultaneously, not one after the other, right? So when you pull, you're saying first fetch, then merge. It's just a convenience mechanism. And someone once asked me, if you do a pull and the merge has conflicts and it gets aborted, did the fetch still happen? And the answer is yes. It's a 2-step process. So with this new freshened up code base, AdventureCat can then find the point that she wants to diverge and create a branch. And so in this open source community, this would be like someone trying to contribute to an open source project. So, you know, there are typically team rules and processes around these things, but AdventureCat comes along and says, okay, I need to branch off of develop. This is the head of the develop branch, so I'm going to then say checkout-B issue 287 or whatever she happens to be working on. Any questions?
One, and it's maybe outside of Git itself, but is there a feature similar to TFS, gated, which code has to successfully build after it's been checked in before it's accepted into the repo?
Yes, you can integrate with your source, with your continuous integration tool of choice. In fact, the article that I referenced earlier, I just wrote it. It's a guest blog article on Stackify.com, their blog. It's called Managing Teams and Organizations in GitHub. It refers to gated. They don't call it gated. It's called like restricted, like branch restrictions or branch protections. And so I have several links in that article that talks about how to set those up. and refers you over to the GitHub site. That article is very specifically for GitHub, but similar types of features exist for Bitbucket Server and probably GitLabs. To be honest, I haven't used their stuff too much. Okay. I'm going to keep rolling because I don't want to run out of time here. I want to talk about staging, which is the process of getting code into your repository only on your local device, okay? So when AdventureCat is working on issue 287, remember that it's just a branch, which is a set of files, right? It's the same files with a different set of changes applied to them. But at the moment, there are no changes because she just started, right? So this is the stage. These files over here represent what the repository currently knows about. It's a bunch of files. The repository knows if you're touching these files. But let's say you have some new files. This particular one here, the one that's grayed out, is ignored. And the way that Git ignores it is using this .gitignore file. So this is a hidden file that you can create if it doesn't already exist for you, and you can tell it using glob patterns what you want to ignore. So for example, let's say this is a log file or a text file or a .env file. Those are good examples of things you might never ever want to check in and may even contain sensitive information. So that's how you would tell Git, hey, just don't ever worry about this file. These other two are simply untracked, meaning that Git sees them and it will, on the command line, it will say, hey, what do you want to do with these files? At that point, you can use the add command. The add command stages those two new files, and in the process, it brings them under the umbrella, which is this pink area, so that it starts to monitor changes to those files. Once they are staged, that's literally, I know it's a little cheesy, but I'm literally using a stage here. So files are moving from left to right in this flow, and you have added them, and then you commit them. And when you commit, you provide a commit message. Very strongly recommend that you have a commit message that is meaningful to both you and your team. So maybe issue 287 involves adding some config files. So that's the first thing that AdventureCat does. Then AdventureCat modifies some of those existing files. You can add just one file. You would say git add file2.txt or whatever, and commit that as well, right? So notice in this diagram that the purple one, file one, let's call it, is still modified, but you've only added or staged one of the files and committed that one, which is kind of handy. Let's say AdventureCat modifies that file again and adds that file again. So we're ready, we're staging it for commit, and then changes her mind. She's going to use the reset command. So git reset file2.txt, let's say, and that will actually move it from the staging area back into the unstaged area. Checkout -- on the other hand, completely undoes the changes that were made to these files. As a general rule, things with -- tend to be destructive. So that's when you want to be careful. So if you say git checkout -- dot, that the dot actually means all files, right? Or git checkout -- file1.txt or file2.txt. If you were to do it individually, you are completely throwing away the changes that you've made there. Let's say the files are modified once more, and AdventureCat adds file 2 to the stage, goes ahead and commits it, but then realizes that that commit was wrong. She actually shouldn't have made that commit, or realized there was something bad about it, so we need to get it back into the state it was in before. You can use git reset head tilde, and the tilde is just a convention that means the commit that was before head. So head is the last commit that was made, and the tilde means the one before that. There is a whole naming convention around tildes and carets and what that means in the Git tree, but this is the most commonly used one. So what that's going to do is it will take that commit that was just made, right? I'm going back here. This is the commit that was made, And when you use that reset head tilde, it's going to undo that commit and put it back in your stage just like it was before. Git reset -- hard, however, remember what I said about the -- that's destructive, and it rolls things all the way back, meaning these files go back to the way they were originally. So you lose your changes in that. Okay, any questions there?
Not so far.
Okay. All right, so getting into some more advanced concepts, these are just some things to be aware of how they work. Merge, we've already talked about. In merging, you create this merge commit here. Some teams prefer not to do a merge, but rather a rebase. So a rebase takes feature 1, 2, 3 and essentially replays the commits in feature 1, 2, 3 on top of the master branch, like so. That preserves a linear history, and when you rebase and then you merge, you bring that feature 1, 2, 3 code back into master, there won't be merge commits in the process. So the linear history is something that people really like, in the sense that the log is not cluttered up with merge commits. Rebase interactive is the same thing, but what's going to happen is interactive, by the way, is just a flag. So when you pass that flag as an option on the command line, what's going to happen is it's going to prompt you every step of the way. It's going to say, is this okay? Is this okay? And if there are 10 commits, it will prompt you 10 times to make sure that you are rebasing on top of each commit correctly as needed. So this is a bit more tedious, but it's also safer in my experience. So when you want to proceed with caution, or if you're new to rebasing, you might want to do that. Cherry picking is a very, very handy tool to have in your toolbox. So let's say, for example, you've got feature 4, 5, 6 and feature 1, 2, 3, and the end commit here on feature 1, 2, 3 was actually made in error. This commit here was supposed to be made over on feature 4, 5, 6. So what you can do is you can cherry pick that. The tennis ball color here is indicating that what's happening is this commit here is literally just being copied on top of this feature 4, 5, 6 branch. So that helps you when you've already pushed a commit up to the cloud, and then you realize, oh no, I committed that to the wrong place. Now, something interesting about cherry picking is that it's not destructive. So when you're done with cherry picking, that bad commit is still there on feature 1, 2, 3. Well, that's not good, because we've got it copied over here. That's great. That's where it's supposed to be. But now we have to get rid of this head commit here. So there are a couple of things you can use for that. You can use a reset with a force push. Forcing is rewriting history. So again, you want to be careful about how you use that. But if you're on a branch and you're the only one who's doing work here, you can reset to this. You can reset the branch to this commit here and then push up to the cloud, and you won't have anything. You won't have any other commits beyond that point. Reset with a force push isn't always the best solution. What you could do is a revert. So let's say again that this commit is bad and wrong and we don't want that here. You could use a revert, which actually does an undo. So if, for example, I changed a button from green in this one to red, and that was a mistake, I actually want to change it back to green. This commit here undoes it, right? So whatever I did in this commit, it undoes it and makes a new commit, and so the button will be green again. Quick note on that is that you don't want to use revert if this contains any sensitive information. So if you have accidentally checked in a password or something, first of all, go change your password because it's technically compromised, and then figure out how you want to fix it. But a force push may be more appropriate than a revert in that situation. Bisect, real quick, is just a way of binary search tree, searching the Git lineage in a binary search tree fashion so that you can triangulate a problem. You have a bug that exists here, but it didn't exist here. And then in the middle, Git will present you that commit and say, hey, is it broken? And what's great about this is that you can mark it good, bad, and it will help you, but you can also pass it a unit test and it will triangulate the offending commit for you. And if that isn't a testament to unit testing, I don't know what is. Submodules is a concept where you can have repos inside of repos. This gets really kind of tricky and weird, but it is something that some companies are doing. One warning on this is that you can actually have Git inception where you have repos inside of repos inside of repos. And if you're new to Git, I just wouldn't recommend that. It's kind of mind-bendy. Okay, so finally, some useful tips and tricks. Git status is a command that I type probably 500 times a day. And because I type it so much, I have an alias set up for it, just S. I type S, enter, S, enter. And what that does is on your local machine, it tells you what files have been staged or changed, modified, and what the status of your local working directory is. Git log will actually show you the full history of the branch that you happen to be on at that moment. Note, however, that when you do git log locally, it's going to be from newest to oldest. And when you're looking at GitHub or Bitbucket, they may do it the other way around. They may have oldest to newest. So just pay attention to the chronological order of the log. And you can also make this pretty. Literally, there's a command called pretty, and if you Google git log pretty, you'll be able to customize it and have it look the way you like. Stashing is almost like a clipboard. You copy those files into a local file. It operates like a stack. If you are using this a lot, I would encourage you just to make a branch instead. Aliases are something that you can and should do if you get really, really comfortable on the command line. Here I'm showing how I have my aliases set up. These are just a few that I use. Once I know what I'm doing, I set up these aliases. And the nice thing is that I have an RC file that is synced in the cloud. So for example, if I have Dropbox or Google Drive available, I can just pull that file down and keep it up to date using a syncing tool. And no matter what machine I'm on, I have my aliases available. Diffing is another one. Diffing can be kind of cumbersome in the terminal, and if you're kind of not comfortable with that, this is where I kind of hop out of the terminal. I use Beyond Compare. There are other tools like Meld, WinDiff, etc., and you can integrate those with Git, which is really handy. So I think that wraps up my slides. 3 minutes to spare, and so hopefully we have time for any other questions that might have come up.
All right, so probably the quickest one is are there any good Git UI wrapper tools that you'd recommend?
SourceTree seems to be the most popular. Also, Visual Studio and the way that they integrate with Git is fine, I think, for making commits. So I wouldn't discourage you from using a UI tool if you're simply making commits. So you're changing code, commit it. Changing code, commit it. That's all good. What I would urge the person who asked the question to consider is that if you're doing anything beyond just making commits, I would go to the command line. Again, I'm stressing the importance of the command line because I think that it really reinforces Git concepts and will turn you into a Git power user, I promise.
All right, one more question, and the person asked, just for clarity, when I'm working on my changes in my local repository, those changes, do they get staged, or do I have to submit a command in order to stage files that I'm working on?
Okay, staging and adding are essentially the same thing. When you add files, it stages them. So it's a multi-step process. Nothing will really do that for you, but you can. You've modified a file. If I type git status, then it will show that that file is read, as in modified. When I say git add that file.txt, it's going to stage it. It's the add command that stages it. And then from that point, I type git commit and then a message. It's -m and then my message goes inside of there, like I changed this file for this reason. So state and also note that you can stage a file and then change it, continue to change it, and those things are actually considered separate. So just because it's staged doesn't mean it's going to pick up those changes. You need to restage it if you've modified it once more.
All right, great. Thank you very much, Lyndsey, for this talk. It was excellent.
Absolutely. Thank you very much.